Welcome to Correct Science. Today we are going to solve the questions we saw in the previous video. If you've not seen that video, you can watch it to try the questions on your own. In this video, we'll be solving 3 of those questions. In the subsequent videos, we'll solve the other ones. Okay, let's look at the question. So the first question was on sets. And the question reads, of 20 adults, 5 belong to A, 7 belong to B, and 9 belong to C. If 2 belong to all 3 organizations and 3 belong to exactly 2 organizations, how many belong to none of these organizations? How do we solve this question? So the question didn't require or didn't ask us to illustrate the information on the Venn diagram, but we have to do so to make our work easier. So how do we illustrate the information on the Venn diagram? This is our Venn diagram. So n of A equals 5, n of B equals 7, n of C equals 9. Let's represent the number of people who belong to none of these organizations by the letter X. Good. Now, for A only, let's represent it by small letter A. For B only, small letter B. And C only, small letter C. Now, from the question, 3 belong to exactly 2 organizations. Meaning, from what I've drawn here, P plus Q plus R equals 3. P is A and C only, so belonging to only 2, right? Exactly 2. Now for A and B, let's represent it by Q, and for B and C, R. So only is the keyword. Okay. Now how do we solve this question to find X? All we do is, first of all, let's find an expression for A only, B only, and C only. So for set A, we know that this whole thing, considering this whole set, this circle, A, Q, P2 are in this circle. And we are saying the sum of these will give us what? 5. So when we do that, we can get an expression for A and say A equals this. Simple. Now for set B, we can get an expression for B only, which is small letter b, to be 5 minus Q minus R. Simple. For C, we have C equals 7 minus P minus R. Simple. So how would this help us? Because we are not seeing X anywhere here. So you might be wondering. But don't worry, as time goes on, we get to know how it will help us. So all we do is we add everything we see here. So we are saying that this plus this plus this plus this plus this plus this will give us what? So the sum of all these things we see will give us what? 20. 20. That's the number of adults. But we know that P plus Q plus R equals 3. So let's substitute that value into this equation we have. So we have 3 plus 2 plus A plus B plus C plus X equals 20. And so we see A, B, and C with X. So how do you eradicate A, B, and C? All we can do is to substitute our values once again. So here we found that A equals 3 minus P minus Q, B equals this, and C equals that. We substitute the values into it. And we send the 5 to the other side. So 3 plus 2 becomes 5. And when we send it to the other side, we have 20 minus 5, giving us 15. Now, we have 3 minus P minus Q plus 5 minus Q minus R plus 7 minus P minus R plus X. How do we go about this? All we do is to group like items. So all those with P, we put them together. All those with Q, we put them together. All those with R, we put them together. So we have this 3 plus 5 plus 7 minus P minus P minus Q minus Q minus R plus X equals 15. So we'll look for the brother for each of them. And now we have it here. So 3 plus 5 plus 7 is 15. 15 minus 2p. So you see the p is what? 2. There are 2 p's, but they are negative. So negative 2p. So 15 minus 2p minus 2q minus 2r plus x equals 15. But we don't know the values of p, q, and r. So how do we solve this question? That's something to think about. But from the question, it says 3 belong to exactly 2 organizations. And we know P plus Q plus R equals 3. So if we try to factor out -2 and have in brackets P plus Q plus R, then we can do something. We'll send the 15 to the other side and we have 15 minus 15. We have x equals, so when you have 15 minus 15, you get 0. When you send the -2 multiplying P plus Q plus R to the other side, we have a +2 multiplying P plus Q plus R. And we know P plus Q plus R equals 3. So x equals 2 times 3. Therefore, the number of people who belong to none of these organizations is 6. Now let's look at the second question. Or some binary operations. The binary operation star is defined on R. So we know R is real numbers. By AB star CD equals AC minus BD AD plus BC. So here we can see their points on the OXY plane. But we are told to find the identity element under star. But first of all, what is an identity element? So let's say we have 1 plus 1. We get 2. But let's try 1 plus 0. We still get 1. 2 plus 0. We get 2. 3 plus 0. We get 3. So anytime you get the same number, it means that number that you added, you operated with that number, the identity element under that operation. So for addition, anytime you add 0, you still get the same number. So the 0 is the identity element of uh, addition. Very good. What about multiplication? Multiplication. So multiplication too has an identity element. How was it? So for multiplication, anytime you have a number being multiplied by 1, you get the same number. So 3 times 1, you get 3. 4 times 1, you get 4. So the identity element to give you that same number, you operated with it. Simple. So for division and multiplication, for for subtraction, when you have 4 minus 0, you get 4. For division, 4 divided by 1, you get the same number. 5 divided by 1. So I hope the concept is clear, simple. But how do you solve this one? Okay, so it's the same concept. First of all, we have to do something. So we let our identity be xy, xy. So here, since they are in point form, the coordinate form, we can't just use one letter. So we can use the another coordinate form, so xy. Now we are saying that AB star xy. So AB operating with xy. Anywhere you saw C in the given operation, how it looks like. Anywhere you see C, now X is taking that place. Anywhere you see B, Y is so anywhere you see D, sorry, Y is taking that place. So in this one, you can see C here, we place X there. This one we can see D here, we place Y there. We can see D here, we place Y there. We can see C here, we place X there. So simple. And we are saying that when you do all that with the identity element, you get back AB. Wow. Meaning A star XY giving us AX minus BY, AY plus BX giving us AB. So we can equate this to this from what we've done so far. And that will help us find the identity element. So let's look at how it will be like. Okay, so we equate AX minus BY to A since they are the same, and AY plus BX to B. How do we solve this simultaneously? So we'll try to make X a subject in the first equation. And when you take your time to do that, you have a plus by on e. Now let's put that in equation 2. So we have ay plus b multiplying a plus by on a. Multiply through by a, so we have a squared y plus b multiplying a plus by giving us ab. When we do this, we can open up. So for the b multiplying a plus by, we have ab plus b squared y. Now this ab can see his brother on this side, so he like to go and join him. But when he does that, the sign has to change so that he'll be able to uh, adjust himself to his new situation, a new environment he finds himself. So we have a squared y plus b squared y equals ab minus ab. And we know that is 0. So we have y out, a squared plus b squared equals 0. Can simply say that y equals 0. You don't really have to worry about a squared and b squared. Because it's x, y we want. That's the identity element. Yeah. Now you put 0 in equation 1. Or you can simply put 0 into this. So wherever you see y, you place 0 there. And you have x equals a on a. So x equals 1. Simple. So we can say the identity element of this operation star is what? 1, 0. Simple. Now let's try the third question. The third question. Given that f of x plus 1 equals x squared minus 3x plus 2, find f of x minus 3. You can clearly see that this question is on functions. So how do we solve it? Simple. To get x minus 3. Hmm. Someone will say subtract 4. And that person will be right. So what if I say x minus 4 plus 1 will give me x minus 3? The same thing, right? So what if I put this into this? If I do so, if I put this into this, and it means I'll get f of x minus 3. So I've taken my x value to be x minus 4 to get x minus 3. So let's try that and see what will happen. Or I hope you get it. Good, good, good. So what do we have? Okay. So we have f of x minus 4 plus 1 given as f of x minus 3. Now, wherever you see x in f of x plus 1, which is x squared minus 3x plus 2, this x minus 4 there. We have f of x minus 3 equals x minus 4 squared minus 3 multiply x minus 4 plus 2. Now we know from a minus b squared we have a squared minus 2ab plus b squared. So x minus 4 will be what? X squared minus 2 times x times 4. So 8x plus 16. Yeah. So when we do that and we also do the negative 3 multiply x minus 4, what do we have? We have f of x minus 3 to be x squared minus 8x plus 16 minus 3x plus 1 plus 2. And when we do that, we have f of x minus 3 to be x squared minus 11x plus 30. Simple. Someone too could have done it this way. Could have factorized the f of x plus 1. We know that is x minus 1, x minus 2. When you see f of x minus 3, you place x minus 4 wherever you see x. You have f of x minus 3 to be x minus 5, x minus multiply x minus 6. You can replace part, but this will be the same answer. Thank you very much for watching the video. I'll be expecting questions and answers to the other questions in the comment too. Thank you very much.